Okay, so I'm going to start off an equation here, and this is going to involve something new that we haven't really had to do much of. We're going to be using factoring, and we're going to be looking at multiple solutions to a logarithmic equation. So let's take a look at what we have here. Log base 6 of omega minus 16 equals 2 minus log base 6 of omega. Now, if omega bothers you, you could just rewrite this example later on as omega equals x, right? It doesn't matter what variable you use, but I'm just following along with one of the homework examples. So what I want to do, like usual, I would love to get all the logarithms on one side if possible. So let's go ahead and do that. Let's just see what happens. Log base 6 of omega minus 16 plus log base 6 of omega equals 2. Okay, and now, according to the product rule, when you add two logarithms together, we can write that as the product, the logarithm of a product. So we get log base 6 of, what's inside here? We get omega minus 16 times omega. And that's going to be equal to 2. Well, this is great. Now I've got a logarithm on one side, a single log, and a number on the other, so I can rewrite this in exponential form. I'm going to say, well, take a look at the parts of this. 6 to the power of 2 equals this argument. So let's write that out. We'll say 6 to the power of 2 equals omega minus 16 times omega. Okay, or in other words, 6 squared equals omega squared minus 16 omega, and that's it. All right, so this is just a polynomial. We can solve this like we would any polynomial equation. 0 equals omega squared minus 16 omega. And watch what I'm doing. I brought this 6 squared to the other side, so now I have minus 6 squared. I subtracted 6 squared from each side. And I don't see any reason to keep writing 6 squared. Let's just turn this into 36. Okay, well, it's a quadratic of some kind. Let's see if we can factor it. 0 equals, well, there's going to be two parentheses, and they each get an omega. And I need to figure out what numbers multiply to 36, negative 36, but they add up to negative 16. So let's think about the factors of negative 36. We've got, well, obviously negative 6 and positive 6, but those add up to 0. That's not going to work. Negative 9, positive 4. That's going in the right direction, but that adds up to negative 5. I'm not there yet. Let's try negative 12, positive 3. Those add up to negative 9. That's not good enough. And I think the next one is negative 8, positive 2. Negative 18 and 2 add up to 16. That's what I wanted. And multiplied together, they get negative 36. So there we go. Omega minus 18 and omega plus 2 is the way to factor that quadratic. Which means I have two solutions. Omega equals 18 and omega equals negative 2. Now, you might think we're done. What else is there to check? You have to go back to the original equation. I'm just going to grab this whole thing here and bring it down below. So we're going to take a look at the arguments of the original equation and see if this works. So let's test omega equals 18. Well, omega minus 16, I guess that'll be 2, so that's okay. And omega by itself, this guy over here, well, that's just 18. So those are both positive. Both positive arguments. That's really what I'm looking for here. Okay, and if you check out the other solution we had, negative 2, let's test that one. Test omega equals negative 2. So now, what do we have? Omega minus 16, well, that's just, that's really negative. And obviously, omega by itself is also negative 2. So this whole thing's not going to work. Those are negative arguments. And if you remember some of the rules of logarithms, you cannot have negative arguments in a logarithm. So these are what we call, what was the word for these? Solutions of some kind. What was it? Extraneous solutions. These are extraneous solutions. Okay, so the only solution that actually works is omega equals 18, and we ignore the omega equals -2. That's the solution to this one.